Welcome back. In this video, I'm continuing Leetcode daily question. For today, that's 2134 minimum swaps to all ones to part 2. So, a swap is defined as taking two distinct positions in an array and swapping the values in them. A circular array is defined as an array where we consider the first element and the last element to be adjacent. Given a binary circular array nums, return the minimum number of swaps required to group all ones present in the array together at any. Okay, let's get to the examples. We have example 1. This is nums. Um, okay, so we can do one swap. Okay. Here we can do, we have to do two swaps, and this one is already okay. Okay. So my intuition for this example was counting the number of ones, then also finding the start index of ones and end index of ones, and looking what's the difference between the two. So, meaning like in this example, we would find the sum of ones is 3, and start index is 1, and index is 4. So 4 minus 1 plus 1, that's how many elements of nums mean. And minus number of, I'm not sure what I said, but yeah, so 4 elements are in between, minus the sum of ones, that would be 1. But we have situation where that is not the case. Right, we had something like this. If we had something like this, wait, yeah, this is the example. If we do it that way, we would count this as a start, this end. We have 1, 2, 3, 4, 5 number of ones, 3 zeros. So it would mean this is 3 swaps, but this is actually only one swap from here to here. So yeah, then another approach that I'm actually going to use to solve this problem is a sliding window. So again, I'm going to find the number of ones and go step by step and check what is the maximum number of ones in window of size of number of ones. And at the end, I'm going to give the number of both sides of the window, so number of ones minus maximum number I found. But because we have a circular array, I'm going to do one more thing, and that's do the same thing but with zeros. So instead of making array bigger or doing modulo on array index, for this sliding window approach, I'm gonna just count the zeros. And why is that? Because let me give an example. So if we had something like this, so imagine this. Maybe like this. Be more easy. So original solution would just go 1, 2, 3, 4, 5, 6. So window would be size 6. and we will find 4. Maximum number of 1's would be 4, and it would require 2 swaps for this place and this place. But actually, for the circular solution, we can just do the same for the zeros and try to group zeros, the sliding window approach. So we just take window of size number of zeros, that's 4, and slide it, and we'll get maximum 3. And that means we only need 1 swap. So I'll take the uh, minimum of maximum in the sliding window of zeros and ones. So okay, I hope it makes sense. Put it up. So first, that's equals sum of sums, get length. We're gonna calculate now the number of zeros. Okay. Now we need to we'll need to have place to store solution. So best will be initialized to number of ones, but most our solution is surely better than. Okay, so I'm sliding. Yeah, probably not. Okay, so for I in range. We'll see. So in range length. So what do we do? If nums of I yeah, current zeros per ones. Okay, so if it's 0, I'll increase the zeros. Zeros else increase. Okay, that first part, and now we need to reduce the number of ones or zeros if the current window is bigger than the sliding window of zeros or ones. So for the zeros, if I is greater or equal to number of zeros, so if I of is 0, okay, we need to zeros is so if it was a 0, then we would decrease by 1, and if it was 1, we would keep it the same. So we can do this. Okay, so number of zeros will be decreased by 1 if 0, and 0 if this is 1. Correct? Also, if I is greater than 1's, so 1's by ones, because if it's 1, then it makes sense. Okay, and now we just need calculate our best. So best is equal to, we want a minimum of of size of window of minimum of current best. So for once, this would be current ones and number of zeros. Okay, and that's accepted. Submit. So the solution is pretty efficient. Um, Space complexity is of 1. Okay, so we don't have anything additional. Size of an input. So yeah, it's of 1 for the space, and for the time complexity, we have one for loop. And this sum and length, so it's off. Very, yeah. Okay, thank you for following, and see you in the next video.